Kia, welcome to the physics tutorial video. In this video, we are going to look at capacitor and capacitance. Okay, so let's start. What is a capacitor? Basically, capacitor is a passive component. And what does that mean? That means it cannot generate power. It's not like a battery. Okay, and we use it to store charge and energy. Okay, so we are going to discuss how can the capacitor can store charge and energy, and in the future when we go to AC, alternating current, and we will talk more about the capacitor's function in the circuit, especially in AC circuit. Okay, so what is a capacitor? Okay, so if we can get two isolate conductor, two pieces of metals, and separate them in the distance, and then this is a capacitor. Okay, and what does it mean? Okay, so we put the two conductor here, and we connect them with a battery. And from the basic conventional current view, we know positive charge is moving out, is flowing out from the positive side of the battery. Am I right? And then they will move into the metal here. Okay, they will move to the metal here, and when they move to the metal here, they will gradually accumulate. Okay, but at the left hand side here, they will create an electric field. Am I right? You learned from electrostatic thing. So we got positive charge and they got electric field. They will repel other positive charge. Am I right? Okay, so the positive charge will be repelled out from the metal. Okay, they'll be moving, will be repelled in this way. Okay, move out. Okay, so gradually they will be moving through or flowing through the wire and back into the battery. So if we put a ammeter here, we can find the current, we can read the current, although there's a gap here. Okay, there's a gap, it's a distance here. Until when positive charge, they will repel each other. Okay, here. Okay, so we got being repelled out. So from this metal, we pay attention on this metal, because the positive charge being moved out. Okay, so we got some extra negative charge accumulate here. Until when? Until if I change the color, say light blue, until the repelling force here, the positive charge is repelling each other, and they will repel the coming force. Okay, until and the force from the battery is going to push it. So when these two forces are equal, and then we say this capacitor is fully charged. Okay, but before that, okay, we will read the current. We can read the current from the ammeter. So now I think basically we see when it is fully charged, and we can see the capacitor charged. Some is stored some charge on the conductors. At this time, if you remove the battery, and we have some positive charge accumulated at this side, and some negative charge stored or accumulated at the right hand side. So this is how we store charge in a capacitor. You can use the electron current view, and they are the same. Okay, I can repeat it one more time here. So we got two conductors, okay, and join to a battery. As soon as we switch it on, and the electron is moving out from the battery, the negative terminal of the battery, and it will be moving into the conductor at the right hand side. And again, the negative charge will repel the negative charge from the left hand side conductor out, move out, okay, repel it out, have a force, push it out, and make it flow into the positive side of the electron. Okay, so similarly, at the left hand side of the conductor, the accumulate positive charge there, and we will accumulate a negative charge at the right hand side until the capacitor is fully charged. So again, no matter you use which view, conventional current or electron current, okay, they have the same result. There will be some charge accumulated at the conductors. And the easiest way to make the capacitor is we call parallel plates. Okay, we have a parallel plates, one here, and then we will accumulate. Okay, I think this is 3D view. Okay, and we can change the one to 2D view. Okay, two-dimensional view is easier to draw. So one at the left, one at the right. So they are capacitor, and we join them to a battery. So the source, the battery's voltage is Vs. Okay, and then we will accumulate negative charge here and positive charge here. And then what? Okay, then I think from year 12 you learned there will be electric field built up in between the plates. Okay, so they are the electric field. Okay, if we have a quick revision from year 12, so this was at SciPad page 241. If you still have your SciPad, you can go have a look. Okay, so for the battery, okay, if we increase the voltage and we increase the electric field, am I right? So what does that mean? That means between the two plates, electric field, the electric field in the electric field between the two plates is proportional to the voltage we apply on it. Okay, another thing, if we keep the voltage, okay, but we change the distance, we make the distance between the plates become smaller and smaller, that means we are moving the positive charge and closer to the negative charge. And in this case, the force between the attractive force between them are stronger. In other words, the electric field is stronger. When distance is decreasing, the electric field is increasing. Okay, and what does that mean? That means electric field is inverse proportional to the distance. Okay, so if we combine these two equations together, we can write what? We can combine them into like E equals to V over D. So electric field is proportional to the distance and inverse proportional to the distance, and that is the formula here. Okay, and if we rearrange this formula, we can write what? We can write V equals to ED. Okay, rearrange the formula. So voltage is ED, and E is electric field. Okay, and D is the distance. So between two places or 2 points, okay, if there's electric field, okay, and there's a distance in between, and then for these 2 points, point A and point B, there will be a voltage between it. Okay, we can measure the voltage. Okay. So apply this concept back to our capacitor. What can we see? Okay, we can see electric field in between. So the electric field between the two conductors, okay, or the two plates, and there's a separation, so there's a distance between them. So therefore we know from the positive charge and the negative charge there is a voltage exist. Okay, so V across the capacitor. So if we join a voltmeter here, okay, and we will see this is the voltage of the capacitor, and when the voltage of the capacitor equals to the voltage of source or the battery, then it is fully charged, because there's no battery cannot push any further any charge into the capacitor, so it's fully charged. So this is the first thing. We know there's a voltage between the two plates. Okay, and again, what does it voltage mean? If we review the year 12 static potential energy, okay, from last year's side page 247. For example, if we want to move the positive charge from A to B, and we need to do work to against the electrostatic force from electric field. So that means we need to apply a force to against, this is the electric field, and there will be a repelling force here, Fe, from the electrostatic force. And the force we need to apply, F, if I write external, okay, external will equals to the electrostatic force, which is QE, okay, Q times electric field, charge times electric field. And from A to B, the distance we travel is distance. So the work we have done from the external force and to the distance will equals to QE times D. This is the work we have done to the charge and convert it into its potential energy. And this is what this formula means. And if we combine this one and the one we just talked about, okay, V equals to ED, okay, V equals to ED. Delta EP equals to electric field times charge times D. And the one we just learned is V equals to ED, electric field equals to ED. And it's easy to see, E is here, D is here. Okay, so we can rearrange the formula to become V equals to ED, and which is what? Delta EP over Q. And what does that mean? That means for every coulomb or per unit charge, which is this one, per unit charge. And for between two positions, and they will gain or lose the energy or the electrostatic potential energy. A very easy or common example is, for example, we have a battery from supermarket, 1.5 volt, and we connect it to a light bulb. So for the electron, from the conventional current view, okay, we got positive charge, move from here and go through the light bulb, okay, and back to the negative side here. This positive charge will gain 1.5 joule of energy, gain energy here, okay, and then they will use up, the energy is used up here from the light bulb, okay, and convert into what? Into light and heat. Okay, so this is the idea of voltage, or the concept of voltage between these two positions. Okay, the electron or the charge will gain 1.5 joule, okay, of energy when there is 1.5 voltage difference. Okay, so if we apply these two concepts, okay, and back to our original capacitor, and we see what? After you connect to a battery and the charge is accumulate at the both side, both plates, and they build up an electric field, and this electric field cause a voltage or potential difference between two plates, and that is what? V also equals to potential energy per coulomb. Okay, so from here, and we can see the capacitor is stored charge and also energy. So this concludes our very basic introduction of capacitor, and also a revision of the electric field and also the electrostatic potential energy.